taken the benefit of that. Now on to the topics for week 5. This week you'll be learning about the slope of the curve at a point, finding the tangent line at a given point, and the derivative of a function at a specific point. This is all covered in section 3.1 of your textbook. These are all referring to the same basic concept, and you'll see on the right side here, there's a lot of names for using the same exact formula. So questions on the AP exam could take any of these forms. Could ask you to find the slope of the graph, the slope of the tangent to the curve, the rate of change of f of x with respect to x, the derivative f prime of x sub 0 at a point, or find the derivative using the limit definition of the derivative. And you'll find that word limit is used because that is what your formula is. You are solving a limit. So let's look at that limit definition of the derivative. The derivative of a function f at a point x sub 0, denoted as f prime of x sub 0, and that little apostrophe there is the symbol for prime or the first derivative. And yes, you will find later on that there are second derivatives, third derivatives, fourth derivatives. But this week we're just going to worry about the first derivative, which is why there's just one apostrophe mark. So to find that derivative, we take the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0, all divided by h, provided this limit exists. If the limit doesn't exist, then the derivative also will not exist. But that's something you'll worry about way later. So how are we going to use this formula? We are going to plug it in. And by it, I mean the original function. Instead of writing f, we'll use the function. And once we've substituted and put that function in, we're going to reduce this mess algebraically. So let's go ahead and look at an example here. We're trying to find the slope of the curve, y equals 1 over x, at any point a, x equals a, where a does not equal 0. Why is it important that we mention that a does not equal 0? Well, let's plug 0 in. Then we get 1 over 0. We cannot have a 0 in the denominator. This is an undefined value. So that a equals 0 is just reminding you that that is your undefined value. And if you look at this graph, you can see that there is no clear x value for 0. Now a could really be any other point besides 0. So if we are trying to find the tangent lines, we're trying to find a line that touches the curve in one exact spot. And then we're trying to find the slope of that line. Now, because we're dealing with a variable here, we don't really have the luxury of just looking at the graph and trying to guess. This one we will have to solve algebraically. You will see examples in your homework that ask you to try to approximate using graphing. But when we're looking at examples that ask you for any point where x equals a, you know you're going to be using a variable and you're going to need to solve algebraically. So with that in mind, let's go ahead and try to solve this algebraically. I'm going to write our formula up at the top so we don't forget it. All right, so there is our formula. We know our x sub 0 is the variable a, and our function is 1 over x. With this information, let's go ahead and plug into our formula. We want to find the limit as h approaches 0 of 1 over a plus h minus 1. Oops, sorry about that. Minus 1 over a, all divided by h. Now, instead of writing h as the denominator, I'm going to rewrite this as the limit as h approaches 0 of 1 over h, so that way we don't have fractions on top of fractions. Now I'm going to try to find a way to subtract these two fractions with different denominators. And of course, we have to find a common denominator, multiply the top and the bottom by that common denominator, and then subtract. So I came up with a minus parentheses a plus h, all divided by a times a plus h. I got that by multiplying the first fraction by a over a and the second fraction by a plus h over a plus h. And from there, I just distributed and simplified. So with that in mind, let's keep going. So now we're going to start trying to simplify this further and get to a place where we'll be able to plug in that h approaches 0. First, we need to distribute that negative sign. The first fraction does not change. We have a minus h over a times a plus h, and that's still multiplied by 1 over h. We have a minus a, which we know is going to cancel out, which leaves us with negative h on top. If we multiply across the bottom, we'll get a times h times a plus h. Now we have an h on top and an h on bottom. We'll be left with a 1 on top and just the a times a plus h on the bottom. With this in mind, we are ready to go ahead and plug in that h equals 0 value. So we want to find the limit as h approaches 0, negative 1 over a times a plus h. If we plug in 0 for our h, that h value is going to go to 0, and we are going to be left with negative 1 over a squared. So the slope of the curve at any point x equals a will be negative 1 over a squared. Now what does that look like if there's a number involved? What if we give you a value for a? You would be able to use this formula to plug in that value for a, and you would have a numeric slope. So if a equals 2, then the slope of your line would be negative 1 over 4. 2 squared is 4, so you get negative 1 over 4. They may also ask you in reverse. They may give you the slope of the line and ask you to find a. When would the slope be negative 1/9? That would be when negative 1 over a squared equals negative 1/9. Or more simply, when a squared equals 9. And that would be plus or minus 3. I hope this gives you a good insight on how to use this formula and how to simplify. By now I know you guys are experts at algebraic manipulation, and I'm sure you guys will be able to have that down by the end of the week. Have a great week. Please email me if you have any other questions or if I can help you at all.